This is 5.3 mean and variance of a binomial distribution for AS statistics. So we've looked at the binomial distribution before and we write it down using this notation. Remember, you must define what that variable x is and you must define what your parameters n and p are within the question. But you may get asked to find the mean and the variance. And we have these two formulas here and they are given in the formula book. This here, you've seen it before in discrete random variables. It's exactly the same notation because remember, the binomial distribution is a discrete distribution, so it's working in exactly the same way as a discrete random variable. But this, we call it the expected value. And you might see that use instead of the word mean. Okay, so you need to be prepared for that. If we just have a quick think about what's happening, if I roll a fair dice 36 times, although 60 would also work, it's fine. And I want to know how many times do I expect to get a 4? Okay, so how many times do I expect to get a 4? If we were writing that down as a distribution, so x would be the number of 4s rolled. And the distribution would be 36, so n is 36. And the probability that I get a 4 on a fair dice is 1/6. I expect to get 36 times 1/6, which is 6 4s. Now, if you just think about that logically, if you've got a fair dice and you roll it 36 times, you would expect that you would get 6 of each number if it was working fairly. Now, you will have looked at that at GCSE in terms of relative frequencies doing exactly the same job. So what the expected value is saying is that if that probability is correct and I do a sample, what if it was perfect, if it worked perfectly and followed that model perfectly, what would be my expected value? Well, if I roll the dice, I would expect to get 6 of each number if I roll it 36 times, and that's what that expected value means. Okay, obviously when we're doing a binomial distribution, because it's following that binary condition, it either happens or it doesn't happen. We would just be focusing on one number there, which is what we did with that 1/6. So let's have a look at these examples. So I toss a coin 100 times. There is a 0.5 probability of the coin landing on heads. What is the expected number of heads? So the first thing that we need to do here is define what our variable is going to be. So we've got x, if we let that be the number of heads. And then we have our distribution, which is x squiggly line binomial. We are tossing it 100 times. And there's a probability of 0.5. Our expected value, so our mean, is equal to NP, which is 100 times 0.5. So we would expect to get 50 heads. And I think, like I said before, logic should get you to that answer anyway. Have a read through part B, so it might be worth pausing the video at this point, do part B, and then play the video and see if you have got it correct. So what we're doing here is we're defining, because I've already used x within the question, I'm going to change my variable, so I'm going to use y. If you have used x, just make a note that you should, within one question, you shouldn't be using the same variable once it's been defined for something else. So this is the number of employees who have suffered with mental illness. I'm putting that into our notation. So we've got y binomial. Well, it was a sample of 200. So n is 200, n is the sample size, and the probability is 6%. So that's what we've identified. So we've got 6%. Put that into decimal form, it's 0.06. So the expected number is the mean, and it is NP. N is 200. Don't know why I've got an extra bracket on there. We'll just ignore that. And the probability is 0.06, which gives me 12. Okay. Moving on. This time we don't have any context, we have just been given a binomial distribution and we want to find the mean and standard deviation. So like I've already mentioned, the mean is just the expected value. So here we would do E of x, which is equal to 0.23, sorry, which is equal to 7.82. And if we're doing the standard deviation, well, first of all, I'm going to find the variance of x, which is equal to np 1 minus p. So those two probabilities there add up to 1. So we've got 34. P is 0.23. So that is just the mean. So that np is just that little bit there. And then we're timesing it by 1 minus 0.23, which is 0.77. So that is just 1 minus 0.23. To find the standard deviation of x, I am just going to do the square root of that answer. So we've got 34 times 0.23 times 0.77, which is equal to 6.0214. So the standard deviation is equal to 2.45. Remember, I am working to 3 significant figures when I am doing this. Okay. If we just go back to this notation, it's worth mentioning here, because it's the expected value, notice that I'm using mu and I'm using sigma, and that's because this is working from a population. Okay, so I'm not I'm doing, the model is representing the whole population, so these are parameters that we are working with, even though n is a sample. So remember, it's x bar when we're dealing with the sample. We'll come on to this next year when we're looking at some of these distributions, and we're like having to take a sample of different distributions to kind of see how all this stuff is working, but just take note of that notation, and that's because we are using this model to represent the whole population. So that's where that's coming from. It is worth just kind of linking all of that together. Let's have a look at 3.3. So pause the video, have a read through this, set up your variable, set up your binomial distribution, and then answer the question. Remember, you can use any value for your random variable. So we could, instead of using x and y, we could use f for 4, okay, or r because you're rolling a dice, whatever you want to do. So it needs to be capital. When I was doing it, never mind. So our binomial distribution is, we're rolling it 30 times. And we've already done one like this, haven't we really? So we've got 1/6 in there. So if I am working out what the expected value is, I've got 30 times 1/6, which is 5. If I'm working out what the variance is, I've got 30 times 1/6 times 5/6. Remember, that's just coming from 1 minus 1/6, which is equal to 25/6. And if I am working out the standard deviation, I take that answer and square root it. I suppose if we are given our answers to 3 significant figures, oops, just drawing random lines, that would look like that. Sorry, the writing is all spread out. I'm having board issues. But anyway, I think we can still read it. So what you need to do now is have a look at 3.4. Make sure you think about, when you're doing this, why we have a binomial distribution. So try and link that into the first section. So why is this a binomial distribution? Go through the 4 conditions that are required, and then we need to start off by saying what x is. The mean is the expected value. So I want you to pause the video and have a go at this table, please, and then I will fill it in and you can check your answers. So here are the answers to the table. It doesn't matter if you've used different letters to represent your binomial distribution. So I just changed it as we went through. It was a case of picking out the information from the question, so working out what n was and then thinking about the probability. So in the first couple, well, the first 3 questions, it just came from tossing a coin or rolling a dice and knowing how many options you had. From the bottom one, it needed calculating prime numbers, so we had 2, 3 and 5 out of the digits 1 to 6. And then with this bottom question here, so we've got a total of 35 balls in a bag and 10 of them are red, so it is 10 out of 35, 2 out of 7 the probability of getting a red, and our sample size is 7, so that's where that's coming from. So please make sure you understand how to do the first bit. I think finding the mean and the variance is just following a basic formula, isn't it? So that should be okay, but picking out the information from the question in order to be able to write down what that binomial is can sometimes be a little bit tricky. Having a look at 3.5, so you need to pause the video now and just have a read through the question and then just have a quick think about it before you go through the explanation. This is the other type of question that we could get on this topic. So if we're looking at the question here, so we've got some information that we need to work out. Knowing that we're looking at a binomial distribution, we need to know where our probability is and we need to know what our sample size is. So we know that we've got 23% in there, we can see that, and a sample size of 200. We are going to define X to be the number of British Asians passing through during a period of 2 weeks. So I'm just pulling that off here. So this is, we've got a sample of 200 pass-through control during a period of 2 weeks. So that's where we're taking that from, which allows us to use this probability of 23%, because that's 23% of people passing through the border identify as British Asian. So we can pull that off there. But what is the question asking us to do? So the mean number that we've got is 46.1 and a standard deviation of 10.2. Comment on the suitability of a binomial distribution. So how to progress with this question? Well, what do we expect if the binomial distribution is suitable? So if we start with that information within the question, so if a binomial is suitable, just starting point. This is fact. This is what we're given. The mean number of British Asians passing through passport control was 46.1 with a standard deviation of 10.2. That is what the sample told us. So that's the fact. So what we need to have a look at now is the binomial distribution that is given above. So using this information up here, so using these two bits of information, what is the mean and the standard deviation that this binomial distribution will get, and then comment on whether it is close or not to the values that were recorded. So if we start off by defining what x is going to be, so we've defined what x is going to be. Passing through, that should be border control, shouldn't it? Let's put it into the context of the question. Let's not miss bits out. So passing through border control during a period of 2 weeks, that tells us that we have x is a binomial distribution, sample size 200, probability 23%, write it as a decimal or a fraction when we're doing that. So using the distribution, we have an expected value of 200 times 0.23, which is 46, and we have a standard deviation, which is the square root of the variance, remember. So I've got 200 times 0.23 times 0.77, which is equal to 5.92. So doing a comparison, we can say that this is close, but that is nowhere near. Okay, so if we just put that into context, so the mean for this type, therefore this binomial distribution is not suitable. So it wouldn't give us, can't spell at all today, it wouldn't give us a good model to represent this situation from, because we would need to be close on all of them. So you're not looking for it to be exactly the same, but if both of them were close to each other, then you would be able to draw a conclusion that it's a good model, because a model is not going to be exact. It is just a representation to help us make predictions, but in this case, the way that the model is spreading the data out is not good enough, and therefore we should not use this binomial distribution.